So we're going to be getting section 3.2, talking about synthetic division today. And synthetic division is a way to divide a polynomial by a binomial if it is in the form x minus k. So x minus some number, x minus 2, x minus a negative number. So if we want to divide a polynomial by that x minus k, then synthetic division is going to allow us a very easy process to do that. So let me kind of walk you through how this works. This may be something some of you have seen before, maybe something that is new to some of you. The process is pretty simple. It is a much easier way than like a long division that you could do. So the way this is going to work is we're going to start with whatever this number happens to be. Now, notice in our form it's x minus k, so we're only looking at the k part of it. So in this case, where you see x minus 4, 4 is the number that we're going to start with. Okay? And so the way this works is we're going to put the 4. That's what we're dividing by. And then across from this to the right, we're going to put the coefficients of the terms in the top. So in this case, the 3, the 10, and the 40. Now, we do want to make sure that every term is represented. So when I say every term, what we mean is starting with the highest exponent and working your way down. So you'll notice here we have x squared, and then we have x, and then we have our constant. So we start with the power of 2, then power of 1, and then constant. If there's a missing term, which we'll talk about in a few minutes, you have to make sure you're aware of that, and we'll talk about how to deal with that in just a minute. So we're going to start with the 4. Again, that's what we're dividing by. And then out to the right, we're going to put the 3, the 10, and the 40. And then we're going to leave a little space and draw a line. And so the way that synthetic division works is we're going to start by bringing down this first number. So in this case, we're going to bring down the 3. And then we're going to multiply this 3 we brought down, this 3, times 4. So 3 times 4 is 12, and that 12 goes under the 10. And then we're going to add those two numbers. So 10 plus 12 is 22. And then 22 times 4 is 88. And then we're going to add 40 and 88. And we're going to get 128. Now, 128 is the remainder. And so if we were trying to write this out, our answer is going to be from this bottom row. And the variable and exponent on the 3 is going to be 1 down from what it started. So we started with an x squared here. And so 1 down from that would be x. And so this answer is 3x plus 22. 22 is our constant. Plus the remainder. Now we write the remainder as that 128 over whatever we divided by. In this case, the x minus 4. Now, one of the questions that's going to come up is if this remainder ends up being a negative number, do you put minus or do you still put plus? Well, I'm always going to put the plus for this last sign because I want to do plus and then whatever that remainder is. I don't want to have to deal with the sign issue potentially. And so if the remainder happens to be negative, I'll do plus the negative number over the x minus 4 or whatever the number happens to be. But this is our solution when we divide. Now, if you had done a long division, you would get the same answer. It's just a longer process because you actually deal with the x's and all throughout the process. And so synthetic division is a very efficient way to quickly divide a polynomial by a binomial. But that binomial has to be in that form. This doesn't work very well if it's 2x minus 4, or 3x plus 5, or whatever. If that first number is in that leading coefficient for that binomial, if it's not 1, then this gets really complicated. But what we're going to deal with, they're all going to be 1. So let's try another one. So on this one, again, same deal. Our binomial is in the form x minus 3. The 3 is the number we're focused on. And so we're going to divide by it. And then out to the right of that, we're going to put the coefficient of each of the other terms. Again, you got to have every term from your highest exponent down. So in this case, we have x cubed. So we have to have x cubed, x squared, x, and then constant. And so in this case, we do have all of those. And so the coefficient on the x cubed is 4. And then negative 15 for the x squared, and 11 for the x, and then negative 10 for the constant. And then we're going to do the same thing. We're going to start by bringing down this 4. And then we're going to multiply 4 times 3 and get 12. And the 12 goes here. And then we're going to add those. So negative 15 plus 12 is negative 3. And then we're going to multiply again, negative 3 times 3, which is negative 9. And then we're going to add that. 11 minus 9 is 2. And then 2 times 3 again is going to be 6. And negative 10 plus 6 is negative 4. And so in this case, the remainder is negative 4. The way we would write our answer, again, look at your highest exponent in the original polynomial. It's a 3, so go down 1 to the 2. And this is going to be 4x squared minus 3x plus 2 plus that remainder, which is negative 4 over x minus 3. And again, there is our final answer. Again, pretty easy way to divide, hopefully without a whole lot of issues. So for those of you that say, well, I don't understand, maybe this is confusing to you, all you're doing here, let me do this in a different color so you can see. Once you bring down that 4, you're going to multiply. So multiply and then add, and then multiply and then add, and then multiply and then add. And so it's just repeating that. Multiply and add, multiply and add, multiply and add, until you get to the end. And then when you get to the end, your last number is that remainder. Again, if you have any questions about that, please let me know. So what I'd like you to do is try this one. Pause the video for a minute. Try this one on your own. See if you can work it out. So I'll give you 3 seconds to do that. So hopefully you did that. You were able to do the synthetic division here. What is a little bit different about this one is now the number that we're working with is going to be a negative 2. Because remember, our binomial has to be in the form x minus something, right? Well, x plus 2 is the same thing as x minus negative 2. So the negative 2 is the number we're focused on. Again, an easy way to think about it is it's the opposite of this number. So if you go back and look at the others that we've done, we used the opposite of negative 3, which is positive 3. We used the opposite of negative 4, which is positive 4. Well, now we're doing the same thing. We're going to use the opposite of 2, which is negative 2. And so negative 2 is our number. And then, again, out to the side, we're going to have the coefficient of each of the other terms on the top. So we've got 5, negative 6, negative 28, and negative 2. And again, we still have every term x cubed, x squared, x, and constant. So, again, be careful, pay attention to that, because you don't want to miss a term. If you do, it's going to mess you up. So, again, we're going to start like we've done the others. We're going to bring down this 5. And then we're going to multiply and add, multiply and add, multiply and add. So, 5 times negative 2 is negative 10. Then we're going to add negative 6 and negative 10 and get negative 16. Then we're going to multiply negative 16 times negative 2 and get 32. And negative 28 plus 32 is a positive 4. And 4 times negative 2 is negative 8. And then negative 2 minus 8 is negative 10. And again, we have a remainder of negative 10. So our answer here, when we do this division, again, we started with an x cubed, so go 1 down from that. It's going to be 5x squared. And then it's every term going down until you get to the constant. So minus 16x plus 4 plus our remainder, which is negative 10, over x plus 2. And so again, there's the final answer. And again, this is a much easier process than, say, a long division. In some classes in the past, we've taught long division, and it's just like long division from when you were in elementary school, but it's with x cubes and x squares and x's, and so that becomes somewhat complicated